Okay, so that's the summary of greedy algorithms. Then again, we discussed briefly the dynamic programming techniques. So let me very, very quickly summarize what we have covered so far. So like greedy algorithm, we are using it for optimization problems. And the key point is to construct this equation, right? So that says, how do you solve, find the optimal solution to your problem in terms of optimal solution to subproblems, right? So the crux of dynamic programming is to recognize the structure and writing down that equation, right? Once you have done that, the rest is, mundane, right? And mundane in the sense that, okay, so once you have written that recursive structure, then you can use that to build a dependency graph. And once you have the dependency graph, then you can evaluate the optimal solution bottom up in this dependency graph. And that's what this topological sort is trying to tell you. Okay. So basically, how do you... And we looked at several examples, and so these are some of the commonly occurring cases in terms of subproblems. So a prefix or a prefix of two different strings, or a substring, and so on, and depending upon the number of subproblems, you have more or less complex. More or less overall complexity for the dynamic programming algorithm. But again, the key to dynamic programming is being able to understand what is this optimal structure, right? So once you've done that, everything is easy, right? And don't get bogged down in some of the details, right? So the most important thing is, can I look at a problem and see whether this, what is this relationship between optimal solutions to subproblems, right? So once I understand that, the rest is pretty mechanical. Now, as I said before, I'm not going to give you a problem that requires dynamic programming a solution and then expect you to be able to solve it in this exam, right? Not this exam. Next midterm, that certainly will be there. But right now, all I'm expecting you to know is, some general idea of what dynamic programming is. What are some of the dynamic programming algorithms that we have talked about? Longest increasing sequence, and then longest common sequence, subsequence. Obviously, I would expect you to know that longest common subsequence is the same thing as edit distance algorithm, and that the same algorithm can be used to solve approximate prefix and approximate suffix and approximate substring problems, right? Again, you don't have to necessarily remember exactly how to do it, but you should really know what algorithms you have studied, what are the complexities of those algorithms, right? So for instance, I would like you to be able to recognize when there is an instance of an edit distance problem involved, okay? So you don't have to know exactly how the edit distance algorithm works, or even compute the edit distance, because I think that's might be a bit time consuming. But I would like you to be able to recognize that here is a problem where by applying edit distance I'll be able to solve it, right? So that's something that I would like you to be able to do. Yeah, so nothing else here is that important. So we can, yeah, I'm done. So if you have any questions, I can answer them, or else we can, yeah.
In the homework, in the last homework,
yes,
there was a Ternary-Hoffman question.
Okay.
And I didn't get the proof that was in solution.
Okay.
I mean, I understand the idea.
Now I have to first look at it, right? So how many people here are interested in that problem? Because I don't want to hold up everyone this late in the class. You can always, if only you are interested, then you can always